cosmic explorers. Welcome back to another incredible journey through the universe. Whether you've just discovered our channel or you've been traveling with us through the stars for a while, I'm absolutely thrilled you're here today. To those of you who are already part of our amazing community, our subscribers who never miss an adventure, thank you. Seriously, thank you. Your support, your enthusiasm, and your curiosity about the cosmos make everything we do possible. You're not just viewers, you're fellow explorers on this incredible quest to understand our universe. And if you're new here, welcome aboard. You've just stumbled into a community of space enthusiasts, curious minds, and people who believe that the universe is the most incredible story ever told. We explore everything from the smallest particles to the largest structures in existence, from the birth of stars to the mysteries of black holes, from the search for life beyond Earth to the mind-bending physics that governs reality itself. Now, if you're enjoying what you're seeing, if these cosmic adventures spark something inside you, if you find yourself wondering about the universe in ways you never have before, I'd love for you to hit that subscribe button. It's free. It helps us reach more curious minds like yours, and honestly, it means the world to us. Plus, you'll never miss our latest expeditions into the unknown. But here's something I'm genuinely curious about, and I hope you'll indulge me. In the comments below, tell me where you're watching from. Are you gazing up at city lights that hide the stars? Are you in a small town where the Milky Way still paints the night sky? Maybe you're on the other side of the world, watching this at sunrise, while I recorded it at sunset. There's something beautiful about the fact that no matter where you are on this pale blue dot we call home, we're all looking up at the same universe. We're all made of the same stardust. We're all part of the same cosmic story. So, drop a comment. Tell me your city, your country, maybe what you can see when you look up tonight. Let's create a map of curiosity that spans the globe. Let's see how far our community reaches across this planet as we explore what lies beyond it. Are you ready? Because today we're embarking on one of our most ambitious journeys yet. We're going to explore our entire galaxy, the Milky Way, from our quiet corner of the Orion Arm all the way to the supermassive black hole at its heart. Hit that subscribe button, settle in, and let's discover the incredible story of our cosmic home together. The adventure begins. On a clear, moonless night, far from the glow of city lights, you can see it. A ghostly river of light stretching across the heavens, so faint it seems like a trick of the eye. The ancient Greeks called it Galaxias Kyklos, the Milky Circle. We know it simply as the Milky Way. But what you're seeing isn't just a pretty streak in the sky. You're looking at your cosmic address, a sprawling city of 400 billion stars, including our own sun. You're seeing our galaxy from the inside, edge on, like trying to map a vast metropolis while standing in its center. Tonight, we're going to journey through this stellar neighborhood we call home. We'll travel from our quiet suburban corner to the bustling downtown core. Explore the spiral arms that give our galaxy its elegant structure, and venture to the mysterious dark heart that holds it all together. This is the story of the Milky Way, not just as astronomers see it through their telescopes, but as the dynamic, ever-changing cosmic ecosystem that has shaped our existence and continues to evolve around us every moment of every day. Mapping the invisible. For most of human history, we had no idea we lived inside a galaxy at all. The Milky Way was just that mysterious band of light, dismissed by some as celestial mist, by others as the path of souls traveling to the afterlife. It wasn't until 1610 that Galileo first turned his telescope toward that fuzzy stripe and made a startling discovery. The Milky Way wasn't mist or vapor. It was made of stars. Countless stars, so distant and numerous that they blended into a continuous glow. But even then, we didn't grasp the true scale of what we were seeing. It took until the 920s for Edwin Hubble to prove that those strange spiral nebulae scattered across the sky weren't clouds of gas in our own cosmic neighborhood. They were entire galaxies, island universes, as he called them, each containing billions of their own stars. Suddenly, the universe became unimaginably vast, and we realized we were citizens of just one galaxy among countless others. But which galaxy? And what did it look like? Here's the challenge that has frustrated astronomers for over a century. Imagine you're standing in the middle of a dense forest, and someone asks you to draw a map of the entire forest. You can see trees nearby, but the deeper woods fade into shadows. You can't fly above the canopy to get the big picture. That's exactly the problem astronomers face mapping the Milky Way from Earth. We sit about 26 light-years from the galactic center, embedded in one of the spiral arms. Dust clouds block our view in many directions, especially toward the galaxy's heart. It's like trying to see through fog. The very materials that make stars also hide them from our view. But astronomers are clever. They've learned to see with more than just visible light. Radio waves pierce through dust clouds that stop ordinary light cold. Infrared radiation reveals the heat glow of stars hidden behind cosmic veils. X-rays and gamma rays show us the most violent, energetic processes in the galaxy. Slowly, painstakingly, we've assembled a portrait of our cosmic home. The Milky Way is a barred spiral galaxy. Imagine a cosmic pinwheel with a bright bar-shaped hub at its center and graceful arms spiraling outward. It's roughly 100 light-years across and contains somewhere between 200 and 400 billion stars. To put that in perspective, if every star in our galaxy were a grain of sand, you'd have enough to fill several Olympic swimming pools. And our sun? It would be just one unremarkable grain among all those billions. But the Milky Way isn't just a collection of stars scattered randomly through space. It has structure, neighborhoods, a complex architecture that tells the story of billions of years of cosmic evolution. The Galactic Suburbs. Let's start our tour where we live, in what astronomers playfully call the Galactic Suburbs. We are located in a minor spiral arm called the Orion Arm, or sometimes the local arm. It's not one of the galaxy's major highways, more like a side street connecting two main boulevards. Our solar system sits in what you might call a cosmic sweet spot. We're far enough from the galactic center to avoid the chaos and radiation that plague the inner regions, but not so far out in the sticks that heavy elements needed for rocky planets and complex chemistry are rare. This isn't an accident. The location where life can flourish, what scientists call the galactic habitable zone, forms a ring around the galaxy's center, roughly where we find ourselves. Too close in, and deadly radiation from the supermassive black hole and frequent supernovas would sterilize any world. Too far out, and you don't have the heavy elements like carbon, oxygen, and iron that make rocky planets and complex molecules possible. But even in our quiet neighborhood, space is far from empty. The local arm contains young, hot blue giants that live fast and die young, exploding as supernovas that enrich the surrounding space with heavy elements. We see ancient red giants in their final death throes, puffing off beautiful planetary nebulae like cosmic flowers. And everywhere there are stellar nurseries, vast clouds of gas and dust where new stars are being born even as we speak. One of the most spectacular of these star-forming regions lies just 500 light-years from Earth. The Orion Nebula is a stellar maternity ward where hundreds of baby stars are taking their first breaths. Through telescopes, it glows like a cosmic jewel, its gases heated to incandescence by the fierce radiation of newborn suns. But stars aren't born alone. They form in clusters, sometimes hundreds at a time, from the same giant molecular cloud. Most of these stellar siblings eventually drift apart as they orbit the galaxy, but some clusters stay together for millions or even billions of years. The Pleiades, those 7 sisters visible to the naked eye, are one such stellar family. blue, hot blue stars still surrounded by wisps of the nebula from which they formed. Our own sun likely formed in such a cluster about 4.6 billion years ago. Its siblings have long since scattered across the galaxy, lost among the billions of other stars. Somewhere out there, perhaps dozens or even hundreds of stars share our sun's chemical fingerprint, distant relatives we may never identify. The space between stars isn't the perfect vacuum you might imagine. It's filled with the interstellar medium, thin wisps of gas and dust, the remnants of ancient stellar explosions, and the raw material for future star formation. On average, there's about 1 atom per cubic centimeter out there, in liter sparse by Earth standards, but containing enough material to birth millions of new stars. This interstellar medium is sculpted by stellar winds, shock waves from supernovas, and the radiation pressure from young, hot stars. It forms intricate structures, cavities blown clear by stellar explosions, dense clumps collapsing under their own gravity to form new stars, and vast sheets and filaments connecting it all together like a three-dimensional spiderweb. And threading through everything is the galaxy's magnetic field, invisible lines of force that guide the motion of charged particles. This magnetic field is millions of times weaker than Earth's, but stretched across such vast distances, it becomes a major player in the galaxy's evolution. The spiral highways. Now let's zoom out and look at the galaxy's grandest feature, its spiral arms. From our edge-on perspective inside the Milky Way, we can't see this structure directly, but astronomers have mapped it through patient observation and ingenious detective work. The Milky Way has 4 major spiral arms: the Perseus arm, the Sagittarius arm, the Norma arm, and the Scutum Centaurus arm. These aren't solid structures like the spokes of a wheel. They're more like traffic jams on a cosmic highway, regions where stars and gas collect in higher densities than the surrounding areas. Here's the beautiful mystery of spiral arms. They shouldn't exist. In a simple disk of stars all orbiting the galaxy's center, the inner parts would rotate faster than the outer parts, just like planets in our solar system. Any spiral pattern would quickly wind up and disappear within a few 100 million years, a blink of an eye in galactic time. Yet here we are, 13 billion years after the Milky Way formed, and it still has prominent spiral arms. How is this possible? The answer lies in what astronomers call density wave theory. The spiral arms aren't fixed structures, but patterns that move through the galactic disk like waves. Imagine cars on a highway hitting a construction zone. They slow down, bunch up, then speed up again once they're through. The traffic jam moves slower than any individual car, but it persists as cars continuously enter and leave it. Spiral arms work the same way. Stars orbit faster than the spiral pattern moves, so they periodically dive into and out of the arms during their journey around the galaxy. When gas and dust enter a spiral arm, they get compressed by the increased gravitational pull of all that concentrated matter. This compression triggers a burst of star formation, lighting up the spiral arms with the brilliant blue-white glow of young, massive stars. These stellar nurseries are cosmic fireworks shows. The most massive stars in these regions burn through their nuclear fuel in just a few million years, then explode as supernovas. These explosions trigger even more star formation in nearby gas clouds, creating a chain reaction that keeps the spiral arms bright and prominent. But here's the fascinating part. By the time these massive stars die, they've moved out of the spiral arm where they were born. It's the stellar equivalent of a relay race. Each generation of massive stars lights up a section of the spiral arm, then passes the torch to the next generation before exploding in a blaze of glory. Our own solar system has likely passed through several spiral arms during its 4.6 billion year journey around the galaxy. Each passage would have exposed Earth to increased cosmic radiation from nearby supernovas and young stars. Some scientists speculate these passages might have influenced the evolution of life on our planet, perhaps triggering mass extinctions or spurring evolutionary changes. The spiral arms also serve as the galaxy's chemical mixing bowls. As gas flows in and out of these regions, it carries heavy elements produced by dying stars to new locations. This cosmic recycling program ensures that successive generations of stars are enriched with the carbon, oxygen, silicon, and iron needed to build rocky planets and complex molecules. Between the spiral arms lie what astronomers call the inter-arm regions, quieter neighborhoods where star formation proceeds at a more leisurely pace. These areas are dominated by older, cooler stars that have had time to drift away from their birthplaces. It's a more sedate cosmic suburbia, where middle-aged stars like our Sun spend most of their time between spiral arm encounters. The Galactic Downtown. Now let's journey toward the heart of our galaxy, a region so dense with stars and so shrouded in dust that it remained largely hidden from human eyes until the advent of infrared and radio astronomy. The galactic center is like cosmic downtown, a bustling, crowded, sometimes dangerous place where extraordinary things happen. Here, stars are packed hundreds of times more densely than in our solar neighborhood. If Earth orbited a star in the galactic center, our night sky would be ablaze with thousands of stars brighter than Venus and dozens brighter than the full moon. At the very heart of this stellar metropolis lurks something both invisible and unimaginably powerful. Sagittarius A, pronounced A star, a supermassive black hole containing the mass of 4 million suns, all compressed into a region smaller than our solar system. For decades, astronomers could only infer its presence from the behavior of nearby stars. But in recent years, they've watched individual stars race around this invisible monster at speeds of up to 70 kilometers per second. That's more than 2% the speed of light. These stellar race cars complete their orbits in periods ranging from a few years to a few centuries, their paths precisely following the predictions of Einstein's general relativity. One star, designated STU, has been particularly useful for testing our understanding of extreme gravity. At its closest approach to the black hole in 2018, it passed within just 120 times the distance between Earth and the Sun, close enough to experience time dilation and gravitational redshift effects exactly as Einstein predicted a century ago. But Sagittarius A isn't just sitting there passively. It's an active galactic nucleus, occasionally flaring with X-ray and gamma-ray emissions as material falls into its event horizon. These feeding frenzies can briefly outshine the entire galactic center, pumping enormous amounts of energy into the surrounding space. The black hole is also likely responsible for the Fermi bubbles, enormous structures of hot gas extending 50 light-years above and below the galactic plane. These bubbles, discovered only in 2010, represent the remnants of a massive outburst from Sagittarius A that occurred roughly 2-3 million years ago, recent in astronomical terms, but long before human civilization arose. Surrounding the central black hole is a dense cluster of ancient stars, many of them red giants nearing the end of their lives. These stars formed early in the galaxy's history, when the central region was a much more active stellar nursery. Today, star formation near the galactic center is largely suppressed by the intense radiation and gravitational forces, making this one of the few places in the galaxy where new stars are rarely born. But the galactic center region extends far beyond the immediate vicinity of the black hole. It includes a complex bar-shaped structure, extending roughly 27 light-years from end to end. This galactic bar, made up of billions of stars, rotates as a single unit and helps channel gas inward toward the central regions. The bar also creates a spectacular stellar mixing bowl. Stars that formed in different parts of the galaxy get stirred together as they orbit through the bar's gravitational field. This has important implications for the chemical evolution of the galaxy, spreading heavy elements produced in the spiral arms throughout the central regions. Perhaps most remarkably, the galactic center shows us our galaxy's future. Simulations suggest that in about 5 billion years, the Milky Way will collide with our nearest large neighbor, the Andromeda Galaxy. When that happens, both galaxies' central black holes will eventually spiral inward and merge, creating an even more massive black hole and triggering spectacular fireworks that will reshape both galaxies into a single, giant elliptical galaxy. The Galactic Ecosystem. The Milky Way isn't just a collection of stars scattered through space. It's a dynamic, interconnected ecosystem where matter and energy flow between stars, gas clouds, and the vast spaces in between. At the foundation of this ecosystem is the interstellar medium, that thin soup of gas and dust that fills the space between stars. This material is constantly being recycled through what astronomers call the stellar life cycle. Stars form when gravity pulls together clumps of gas and dust. They shine by converting hydrogen into helium in their cores. When they die, they return processed material to space, either gently as planetary nebulae or violently as supernovas. This cosmic recycling program has been running for over 13 billion years, gradually enriching the galaxy with heavy elements. The first stars were made almost entirely of hydrogen and helium, the primordial elements forged in the Big Bang. But each generation of stars has produced and distributed carbon, oxygen, nitrogen, silicon, iron, and dozens of other elements essential for rocky planets and life as we know it. Our own bodies are living proof of this stellar alchemy. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were forged in the nuclear furnaces of ancient stars and scattered through space when those stars died. We are, quite literally, made of stardust. But the galactic ecosystem involves more than just chemical recycling. Energy flows through the galaxy in complex ways, driven by stellar winds, supernova explosions, and radiation from young, hot stars. These energy sources heat the interstellar medium, creating vast bubbles of hot gas that can expand for millions of light years. The galaxy also has weather, vast streams of gas flowing inward from the outer regions to fuel new star formation, and outflows of hot gas driven by stellar explosions and supermassive black hole activity. These galactic winds help regulate star formation rates and can even blow gas completely out of the galaxy, enriching the space between galaxies with heavy elements. The two central supermassive black holes will eventually spiral toward each other, generating gravitational waves that will ripple through the fabric of space-time itself. When they finally merge, they'll create a single, even more massive black hole, surrounded by a brilliant accretion. But the Andromeda collision is just the beginning of the Milky Way's long-term future. Over hundreds of billions of years, the galaxy will continue to evolve. Star formation will gradually slow as the raw materials, hydrogen and helium gas, are either consumed by existing stars or blown away by galactic winds. The most massive stars will continue their cycle of rapid birth and explosive death. But as the gas supply dwindles, fewer and fewer new stars will form. Eventually, only the longest-lived, lowest-mass red dwarf stars will continue shining, giving the galaxy a dim, reddish glow. Over trillions of years, stellar encounters will gradually disrupt planetary systems and stellar orbits. Even the remaining stars won't shine forever. The smallest red dwarfs can burn for 1 trillion years or more, but eventually they too will exhaust their nuclear fuel and fade to cold, dark remnants. The universe will enter what cosmologists call the degenerate era, dominated by white dwarfs, neutron stars, and black holes. But this far future is almost incomprehensibly distant. The universe is currently only 13.8 billion years old. You have last just 1% of the time it will take for the longest-lived stars to fade. Compared to these cosmic timescales, the entire history of complex life on Earth is just a fleeting moment. For now, The Milky Way continues its ancient dance through space, carrying us along on a journey that began billions of years before Earth formed and will continue for billions of years after our sun dies. We are temporary passengers on this cosmic arc, made of elements forged in the hearts of stars, living on a planet warmed by nuclear fusion, under skies filled with the light of distant suns. Every atom in your body has traveled vast distances to be here. You are connected to every star in the sky through the cosmic recycling program that has been running since the first stars lit up the primordial universe. You are not separate from the cosmos. In a end, you are part of it, a way for the galaxy to know itself. When you look up at the Milky Way on a dark night, you're not just seeing a pretty band of light. You're seeing your cosmic heritage, the vast stellar city that has been your species' home for all of human history. You're seeing the ongoing story of creation itself, the birth and death of stars, the formation of planets, the complex chemistry that makes life possible. This is our galaxy, our cosmic home, the Milky Way.
On a clear, dark night, far from city lights, you can see it with your naked eye. A faint, ghostly smudge against the star-filled canvas of our night sky. What you're looking at is light that has traveled for over 2.5 million years to reach your eyes. You are seeing the past, and perhaps glimpsing our future. This is the story of Andromeda, our nearest major galactic neighbor, our cosmic twin, and our ultimate destiny. It's a tale of discovery, violence, beauty, and the inevitable dance of cosmic titans that will reshape the very fabric of our local universe. For over a millennium, humans have gazed upon this celestial wonder, not knowing they were looking at an entire galaxy containing 1 trillion stars. Tonight, we embark on a journey across 2.5 million light-years of space to explore the most important galaxy in our cosmic neighborhood, ancient eyes and modern revelations. Our story begins over 1,000 years ago, in the courts of ancient Persia. In 964 AD, the astronomer Abd al-Rahman al-Sufi was meticulously cataloging the night sky when he noticed something peculiar, a faint, nebulous star that didn't belong in any constellation. Al-Sufi called it Al-Sufi's Galaxy, though he had no concept of what a galaxy truly was. To him, it was simply a curiosity, a nebulous star that appeared different from the others. Centuries passed. European astronomers like Charles Messier cataloged it as M31, the 31st object in his famous catalog of comet-like objects. Still, no one understood its true nature. By the 1800s, improved telescopes revealed spiral structure in many of these mysterious nebulae. Lord Rosse's drawings showed elegant spiral arms, but the great debate raged. Were these objects within our own stellar system, or were they island universes, as philosopher Immanuel Kant had speculated? In 1920, astronomers Harlow Shapley and Heber Curtis engaged in what became known as the Great Debate. Shapley argued that spiral nebulae were local gas clouds. Curtis proposed they were distant galaxies. The future of cosmology hung in the balance. The answer came 5 years later, when a young astronomer named Edwin Hubble made the most profound discovery in human history. Using the powerful 100-inch telescope at Mount Wilson Observatory, he identified individual Cepheid variable stars within the Andromeda Nebula. These stellar lighthouses allowed him to calculate distance using a technique developed by Henrietta Swan Leavitt. The result was staggering. Andromeda was nearly 1 million light-years away, far beyond our own galaxy. In that moment, our universe became unimaginably larger. We were no longer alone in the cosmos. The anatomy of a giant. Today, we know Andromeda as one of the most magnificent objects in the universe. Officially designated M31, this galactic giant stretches 220,000 light-years from edge to edge, more than twice the diameter of our Milky Way. To put this in perspective, if you could travel at the speed of light, it would take you 220,000 years to cross from one side of Andromeda to the other. If you drove a car at highway speeds, the journey would take over 1.5 billion years. This cosmic leviathan contains approximately 1 trillion stars. That's nearly 3 times more than our own galaxy. These aren't just random points of light, but entire solar systems, many potentially harboring planets, and perhaps even life. The total mass of Andromeda is truly staggering, roughly 1.5 times that of the Milky Way, weighing in at about 1.2 trillion solar masses. But here's the mind-bending part. Most of this mass isn't in stars at all. Like all large galaxies, Andromeda is dominated by dark matter, that mysterious substance that outweighs ordinary matter by more than 5 to 1. When we observe Andromeda across different wavelengths of light, we're essentially doing archaeology. Each wavelength reveals different aspects. Ultraviolet shows us where new stars are being born. Infrared reveals cooler, older stars and dust lanes, while radio waves map out the hydrogen gas that fuels star formation. Like our galaxy, Andromeda is a barred spiral galaxy with elegant arms of stars, gas and dust sweeping outward from its central bulge. But Andromeda's structure is more complex than our own, with multiple ring-like formations and what astronomers call a double nucleus at its center. The stellar generations. Not all stars in Andromeda are created equal. Like people, they come in different generations, each telling a story about the galaxy's past. The oldest residents are ancient red giants and the stars in globular clusters, dense balls of hundreds of thousands of stars that orbit the galaxy like cosmic cities. These stellar ancients are over 10 billion years old, formed when the universe was less than a quarter of its current age. In stark contrast, the spiral arms blaze with young, hot blue stars, some less than 1 million years old. These stellar newborns are born in vast nebulae, where gas and dust collapse under their own gravity. By studying the stellar populations in Andromeda, we can reconstruct its entire history. The metal content of stars, what astronomers call metallicity, tells us when they formed. Early stars had almost no heavy elements, while newer generations are enriched by the deaths of previous stellar generations. This cosmic recycling program has been running for billions of years. When massive stars die in spectacular supernova explosions, they scatter heavy elements, carbon, oxygen, silicon, iron, into space. These elements become the building blocks for new stars, planets, and eventually, life itself. Even smaller stars contribute to this cycle. When stars like our Sun die, they puff off their outer layers, creating beautiful planetary nebulae while leaving behind dense white dwarf cores. These stellar corpses slowly cool over trillions of years, becoming the fading embers of cosmic history, a violent galactic history. Andromeda didn't always look as serene as it does today. Beneath its elegant spiral structure lies a dark and violent history. This galaxy is a cosmic cannibal that has devoured multiple smaller galaxies over billions of years. The evidence is written in streams of stars that orbit Andromeda like ghostly ribbons. These are the remnants of smaller galaxies that were torn apart by Andromeda's immense gravitational pull, their stars scattered but not forgotten. The most prominent of these is the giant stellar stream, a river of stars that extends for hundreds of thousands of light-years around Andromeda. This is all that remains of a galaxy that was completely destroyed, its stars now forever trapped in orbit around their destroyer. When we look at Andromeda's stellar population, we can see the archaeological record of its past. Different generations of stars tell us about different merger events. We can actually identify at least 30 distinct merger events in Andromeda's history. It's like reading the chapters of a very violent book. Perhaps most shocking of all, scientists now believe that Andromeda collided with and completely absorbed a galaxy nearly as large as the Milky Way about 2 billion years ago. This wasn't a gentle merger. It was a cosmic catastrophe that fundamentally reshaped Andromeda. This ancient collision explains many of Andromeda's unusual features: its warped disk, its complex stellar populations, and even its double nucleus. The smaller galaxy didn't go quietly. It left its mark on every aspect of Andromeda's structure. Today, Andromeda still has companions, smaller galaxies called M32 and M110 that orbit like cosmic pets. But their fate is sealed. Eventually, they too will be consumed by their massive parent, adding their stars to Andromeda's already impressive collection. The central monster. At the heart of Andromeda lurks one of the most massive and mysterious objects known to science, a supermassive black hole containing the mass of 100 to 200 million suns. That's 25 to 50 times more massive than Sagittarius A star, the black hole at the center of our own galaxy. This gravitational monster anchors the entire galaxy, its immense pull keeping 1 trillion stars in their cosmic dance. The black hole's event horizon, the point of no return, is larger than the orbit of Earth around the Sun. Supermassive black holes are like the conductors of a galactic orchestra. They don't just sit there passively, they actively shape the evolution of their host galaxies through feedback processes that can trigger or shut down star formation across vast regions. But Andromeda's central region holds another mystery. High-resolution observations reveal what appears to be a double nucleus, 2 bright concentrations of stars near the galaxy's center. For years, astronomers thought this might be 2 supermassive black holes, but we now believe it's an optical illusion created by a ring of stars orbiting the single central black hole. Unlike some supermassive black holes that shine as brilliant quasars, Andromeda's central beast is relatively quiet. It's not actively feeding on large amounts of matter. If it were, Andromeda would blaze so brightly that it would dominate our night sky, possibly even being visible during the day and sterilizing any nearby planets with radiation. The region around this black hole is one of the most extreme environments in the galaxy. Stars zoom around at thousands of miles per second, and occasional stellar collisions create exotic objects like blue stragglers, stars that appear younger than they should be. The cosmic neighborhood. Andromeda doesn't exist in isolation. It's part of our cosmic neighborhood called the Local Group, a collection of more than 80 galaxies bound together by gravity across a region spanning roughly 10 million light-years. The Local Group is dominated by 3 large spiral galaxies: our Milky Way, Andromeda, and the smaller but still impressive Triangulum Galaxy, also known as M33. These 3 giants are surrounded by dozens of smaller satellite galaxies, dwarf ellipticals, dwarf spheroidals, and irregular galaxies. Andromeda alone has over 20 known satellite galaxies, with new ones being discovered regularly. These cosmic companions range from the relatively large M32 and M110 to tiny, ultra-faint dwarf galaxies, containing just a few thousand stars. The Local Group is like a fossil record of how structure formed in the early universe. By studying the orbits and properties of all these galaxies, we can understand how they came together over billions of years through gravitational attraction. The entire Local Group is embedded in an enormous halo of dark matter, that mysterious substance that makes up 85% of all matter in the universe. This dark matter scaffolding guided the formation of galaxies, creating the cosmic web of structure we see today. But even the Local Group, isn't the end of the story. Our entire galactic neighborhood is being pulled towards something called the Great Attractor, a massive concentration of galaxies and dark matter that's drawing us across space at over 1,000 miles per second, the approaching giant. Here's something that might fundamentally change how you think about the future. Andromeda is heading straight for us. Unlike most galaxies in the universe, which are moving away due to cosmic expansion, Andromeda is approaching the Milky Way at 250,000 miles per hour, fast enough to travel from Earth to the Moon in less than an hour. This discovery required some of the most precise measurements in astronomy. Scientists had to detect Andromeda's motion across the sky, its proper motion, which is incredibly tiny due to the vast distance. It's like measuring the width of a human hair from 2,000 miles away. In approximately 4.5 billion years, these two galactic titans will collide in what scientists call the most spectacular event our solar system will ever witness. But don't panic, this won't be a destructive crash like two cars colliding. When we say collision, it's misleading. Galaxies are mostly empty space. The stars are so far apart that very few, if any, will actually collide. Instead, they'll be redistributed into new orbits through gravitational interactions. It's more like two swarms of bees merging than two solid objects crashing. The collision will unfold over billions of years in a cosmic ballet of unimaginable complexity. First, the outer regions of both galaxies will begin to distort as their gravity fields interact. Tidal streams of stars will be flung into space, creating spectacular bridges and tails of stellar debris. As the galaxies interpenetrate, their gas clouds will collide at high speeds, creating shockwaves that trigger massive bursts of star formation. The night sky will blaze with newborn stars, many of them hot blue giants that will burn brightly but briefly. The climax will come when the two supermassive black holes at the galactic centers finally merge, creating gravitational waves that will ripple across the universe. This merger will birth one of the most massive black holes in the local universe. The result will be a new elliptical galaxy that astronomers have already nicknamed Milky Way. This cosmic hybrid will be larger than either of its parent galaxies, containing nearly 2 trillion stars in a roughly spherical distribution. Fate of our solar system. What will happen to our solar system during this cosmic merger? The answer depends on where we end up in the gravitational chaos of the collision. Computer simulations suggest that our Sun has about a 50-50 chance of being ejected from the central regions of the merged galaxy. We might find ourselves in the outer halo of Milky, far from the galactic center where we currently reside. The good news is that the Sun will likely survive the merger relatively unscathed. The bad news is that we might end up in a very different neighborhood, possibly in the outer suburbs of the new galaxy, where the night sky would look completely different. The night sky will be transformed beyond recognition long before the merger is complete. As Andromeda approaches, it will grow larger and larger in our sky. Instead of the faint smudge we see today, our descendants will witness a spectacular galaxy filling much of the night sky. During the height of the collision, the sky will be ablaze with star formation. Brilliant nebulae will shine like cosmic fireworks, and massive young stars will outshine anything in our current night sky.